Hi, I'm Bill Sarur, and welcome to another episode of Mastery Monday. This is a show that happens live every Monday night at 10 p.m., and it's where I try to show you how to improve your code and advance your career. So today I've got something pretty special planned. We're going to be looking at a REST API that was built in Node with Express and MongoDB. But unlike a lot of videos that are about this kind of thing, today's focus is going to be less on how to use the technologies and more on a clean architecture style. So what I mean by that is basically how do you divide your architecture or layer your code such that your business logic is isolated from the various frameworks and technologies that you're using. And so what I'm going to show you is one way of doing that. And I'm hesitant to say that it's like the only way, because it's certainly not, or that it's the best way, because the term best really depends on your particular situation. But I'm sure there's going to be a lot of interesting tidbits that I can share with you about how this code is structured and some of the trade-offs and decisions that appear within the code base that I've had to make. And so I'm looking forward to sharing that with you. You can follow along if you'd like. There's a link to the code on GitHub in the video description and also on the chat if you're watching live. So you may want to go hop over there, put that in a different tab or on a different monitor if you've got a couple, and then we can look at the code together. So let's jump in. Actually, before we look at the actual code, we're going to go and look at the endpoint or the API itself. So this is an API that's very, very basic. I haven't implemented too much functionality. It's just an API for contacts. And right now I've got a post that allows you to add new contacts. And I've got a few get methods that allow you to retrieve all the contacts or a specific contact and a bit of filtering. So I'll show you how it works first, and then we'll jump into the code and take a look at that. So what I've got open here is, whoa, you cannot see me. How about we make sure that you can see me? How is that gonna work? Ooh, I love doing this stuff live. Okay, so, all right. And here I am. Okay, so hopefully I wasn't a blank screen the whole time, and if I was, I apologize, but hopefully the audio came through. So what we're looking at here is a application called Postman, and with Postman you can make HTTP requests to a server and see the results. And so this is the endpoint that I created. As I said, it allows you to post contacts and get contacts. So I've got a contact record here, very simple. It's got a first name, a last name, and an email address. And if I send, it's running obviously on localhost. So if I send this message out and all goes well, we can see that we've got a return value. So it's coming back with an object that has a success flag of true and that says created, and it shows me the contact that was created, and we can see here a new contact ID was added. And if I try to run this again, what happens is I get an error because I cannot call insert with the same email address. The email address has to be unique. So that's one example of one of the business rules that is in this service that I've built. And so if I vary the email address, if I just stick a 1 in front of here, let's say, I can send again, and again we see now it's added the new record, and I'm gonna add a third record just for fun with some completely different values so we can see some variation. Let's say Gmail. All right, send. Okay, so you get the idea about how the post works, and there's validation in here. So if I try to add a contact without an email address, let's say, that's going to error out. Email address cannot be null. Okay, so we've got some validation, we've got some rules going on. You know, it's a standard post, and so the get works similarly. So if we just do a get of contacts, we're going to get back the records we've just added. And I've also implemented a get for a specific contact. So if I just add an ID to the root,
So I get back the specific contact. We can also do a few other things here. So we can set a max, for example. So right now this is returning 3 records. If I set a max of 2, I'm going to get back only 2 records. I can also do some paging. So I'm using the contact ID as a cursor. So if I use the contact ID and I say, get me a maximum of 2 records after this ID, it'll return me the next 2 records after this ID. So if we send, there we go, the next 2 records after that ID. And I can also go the other way, so we can go and get stuff before. So if we flip this around and put this as before, pass that in. So now when I run this, what should happen is I get back 2 records, the two previous records before this ID. And so that's just one way of implementing paging. So you can see it's a pretty basic little API. There's a few rules being enforced. So let's jump in and look at the code and see how that works. So here we go. I'm gonna zoom in. Whoa. I'm gonna zoom in and let's get rid of this. So if we look at the structure here, basically we've got a folder with our package JSON, and then we have a source folder that contains our source code. And in here, the main entry point is this index.js, and then we've got a folder for contacts, a DB folder, and some helpers. And we'll dig into each of these in time. But let's first look at our index.js. So if we come here, give us a little bit of room. So you can see we're using Express. So we've imported it obviously from the standard Express library. We're using body parser just to allow us to receive JSON as our body. So it'll parse that on its way in. And then our endpoints here are our routes are very, very light. So we have this all, which will catch any request to contacts and send it to what I call a contacts controller. And then we have a specific one for get that takes an ID parameter. And then you'll notice that both of these things are being handled by this contacts controller. So contacts controller is just under here. It's just this function right here. And this is a very generic function. All it does is it takes the request that is an object that comes from Express that has, that basically represents an HTTP request, runs it through something called AdaptRequest, which we'll look at in a moment. And then it calls this handle contacts request with the HTTP request, and then it sends a response. So there's very little business logic here at all. And that's because this structure here, this rec-res, this is coming from a framework, which is Express, which we don't control. It's an outside bit of code. And so we have to be very wary, or we should be very wary if we want our applications to last a long time and to be readily changeable. We should be very wary of mixing our business logic too much with concepts that come from frameworks. So the way I look at it is Express is really there to allow you to send and receive messages over HTTP. That's what it's good at. And I mean, there's other functionality too with middleware and so on, but keeping things simple, Express lets you send and receive messages over HTTP, which is one concern. There's another concern, which is about interpreting those messages and formulating a response. And the way that your API interprets the message and the response that you're going to formulate, that's going to be unique to your particular application. And so what we want to do is we want to be careful about mixing things that are unique to our application or too much with things that are coming from a framework. Or another way of saying it is we want to be careful that the custom logic of our application is not overly dependent on a third-party framework. We want the framework to be dependent upon our custom logic. And so we'll look at a couple of things that sort of demonstrate that. So first, we create this HTTP request, and we do that with this little helper function called AdaptRequest. So if we look at that function, so we can go here, and look at AdaptRequest. So this is a very simple little function. All it does is it just takes this request object, which is something that is native to or proprietary to request, and it converts it into a standard object. It maps it into a standard object that has sort of a standard representation of an HTTP request, but just the data of an HTTP request. So we're not passing through some of the methods that come from Express, like rec.send, which actually allows us to send across the wire information. Instead, what we're doing is we're just capturing the data that was in the request so that we can handle and process that. So remember I said sending the messages across the wire, that's the responsibility of Express. Interpreting the message and formulating a response, that's going to be the responsibility of our app. So going back, once we've got this generic HTTP request object, which is just basically, a bag of data that is coming from the HTTP request, we call this handle contacts request function. And so handle contacts request is the first thing that's inside of our contacts folder. And it actually comes from here. This contacts endpoint handler, and the contacts endpoint handler is created from here, contacts endpoint.js. So what contacts endpoint.js is, this it's a factory that creates for us a function that can handle an HTTP request. Okay, so contacts endpoint, if you're following along in the code, it's a factory that creates a function that can handle an HTTP request. Okay, and the reason that we do it this way is so that we can inject a contact list in here, which is what we'll be working with to manipulate the data to add and remove contacts from our list. And the other reason that we do it this way is so that we can build something that is completely independent of any kind of framework. So this handle function, the logic in here, basically its responsibility is to receive a generic HTTP message and create a specific HTTP response object. And so if, for example, the HTTP request happens to be a post, it'll go and call post contact with our HTTP request. And that's over here. And you can see all the logic is in here now to build the response objects, okay, to make a standard HTTP response. And the reason I like doing it this way is because now this module is highly testable. So it's very easy to test this now, because I can inject a mock contact list if I need to, if it gets used in some of the stuff that I'm testing. And also I'm just testing on, given this object, do I get this other object in response? So the function receives an object and returns an object. And for me, that's one of the best patterns in JavaScript, is to write functions that receive an object and return an object, because they're super easy to test. And they tend to be very flexible and easy to change, expand, build upon over time. And so you can see here we're handling the post and the get. And we've got helper functions all throughout here, like make HTTP error, which will just make an object for the HTTP error. But if we focus for a moment on the post, so the post will take the contact info from the request body, and eventually it will make a contact object and add it to our contact list. Okay, so this contact list is coming from here, so it was injected, right? And all of the logic about what makes a valid contact lives inside this make contact, and all of the logic about how to add that contact into our database lives inside this contact list add method, right? So you can see that we're separating concerns. So now we've got one layer or one module that is in charge of sending and receiving HTTP requests. And that module is reliant on a framework. Now we've got another module that is there that understands how to receive and return HTTP request response type objects, right? The data of a request. Then the actual logic, our business logic about contacts, lives again in a separate module. And now we're layering our app and creating a lot of independence. So if we look at this make contact, this is over here. Okay, so this make contact is again another factory function that's going to return a frozen object that represents our contact. But the value of having this make contact function is that it is the place where we can encapsulate all of our business logic. So what I mean by that is there are rules about what makes a valid contact in the context of this particular API. And we want to put those rules somewhere where it's completely independent of any of the other concerns or frameworks of our app. So this is just a plain old JavaScript module. There is nothing in here that is reliant upon any kind of third-party framework at all. In fact, the code in here doesn't even know or care whether it's in the back end or the front end, whether it's serving a web type API, web service type API, or it's just serving a regular web app. It doesn't know the difference because it's very generic and focused on or it's specifically focused on the rules about what makes a valid contact. And so we've got this validate method, right, that ensures that we have a first name, a last name, and an email address. And then we validate the name, which ensures that the name is at least 2 characters long. And if it's not, it's going to throw a custom exception, which is called an invalid property error, with a meaningful message. Similarly, we have validate email, which is going to validate the email address, again using a helper function that tells us what a valid email address is. So if you try to put in an invalid email address, you'll get another custom exception, an invalid property error, that will tell you that this is an invalid email. And then we've got this normalize function that we run everything through. And the normalize function, what it does is it makes sure that the first and last name have an uppercase first character. And it also makes sure that the email address, the entire email address, is in lowercase. So that's how we normalize it. And you'll notice it's impossible to make an invalid contact object. You can't do it because as soon as you try to make it, it's going to run the validate and the normalize. And if you attempt to make a contact with some invalid state or some invalid data, what's going to end up happening is you're going to get an exception. So it's impossible, or it's going to throw an error. So it's impossible to make an invalid contact. And that's a really key point about business objects in general. When you create an object that is meant to represent some concept within the domain of your application, it should be impossible to create that object or put that object in an invalid state. And we further reinforce that by freezing the object that we return, right? And then so when we freeze, object.freeze, if you're not familiar with it in JavaScript, what it's going to do is it's going to make it so that the properties of the object that are returned can't be modified. Now, one small note, it does a shallow freeze. So if you have internal properties, or if you have sub-properties of a contact that are of a reference type, so if you have an array or another object, you need to freeze that as well, so that you deep freeze it, so that you make sure that the outside world, nothing in the outside world can ever take your business object and put it into an invalid state. So that's just a key lesson. And again, notice, none of this code knows anything about Express or HTTP requests and responses, nor does it know anything, by the way, about any kind of a database. It just knows what a valid contact is and how to enforce the rules about a valid contact. All right. And so then we need to look at our contact list. So our contact list It's another factory function. As you can probably tell, I'm a huge fan of factory functions, and I'll try and throw in the description a link to an article I wrote called, about a pattern in JavaScript called an ICE factory, and that's what these are. These are ICE factories. So basically, it's a factory function that returns a frozen object. So here we're making a contact list. Okay, and so this is in contactlist.js in the contacts folder if you're following along with the code on GitHub. And the contact list is there to basically encapsulate interactions with the database. And again, by using a factory function, what we can do is we can inject an object that represents the database, or an object to help us interact with the database. So that means, again, from a testability standpoint, it's very easy to test this now, because if you don't want to have a live connection to the database or be doing live database calls within your test, you can easily mock this out because it's being injected. So it's just dependency injection, right? And so when we look at some of the functions within here, you have sort of what you'd expect out of a list. So you've got add, which allows you to add a contact, find by email, find by ID, get items, which is going to return a bunch of items, remove and replace. I don't think I actually implemented here. No, I think I implemented remove. I didn't implement replace and update. If you want, go to GitHub, pull down the code, and see how you might implement that yourself. It's a little bit of a fun take-home task if you'd like. But so this contact list is, again, interacting with the database so that it's hiding the details of the database from the rest of our application. So when our contacts endpoint code goes and calls, for example, contact list.add, it has no idea what database is behind this. So yeah, right now it's MongoDB, but it could be anything. It could be a SQL database or an Oracle database. It doesn't matter which database is underneath. We've actually completely hidden that detail. That becomes sort of an annoying detail that's hidden away. And the reason that it's really important that we return object.freeze with this stuff is because we don't want code from outside of, we don't want outside code that's consuming this module to be able to change anything. So we don't want them, for example, we don't want any outside code to ever be able to reassign to add or to find by email, because that would put our object in an invalid state. And so with a factory function like this, when you're returning an object, you're making sure that that object remains in a valid state as it gets passed around. And like I said, I'll find a link to the article and I'll put it in the description so that you can read more. I went into some depth about why I like this pattern and why I prefer it to, let's say, classes in JavaScript. But it's not to say that this is the only way. It's just trying to reinforce the underlying principle that you shouldn't ever allow your objects to be put in an invalid state. And one of the ways to protect against that is to make it very difficult for code outside of the object to directly mutate any of its properties. Okay, and so yeah, so this contact list, you could say, is an implementation of something called a repository pattern, but I didn't call it contact repo, and I do that very on purpose. So I try to shy away from naming things in my applications after certain design patterns. And the reason that I don't like to name things after design patterns is because in my experience, what happens is it leads to the wrong kind of arguments within a team. So if I were to name this contact repo or make contact repo, then someone on the team guaranteed would tell me that, well, no, actually, technically a repository is implemented that way. And there would be a large theoretical discussion about what a repository is or isn't. And that's the wrong type of thing to be arguing about when you're building an application and working with a team. What you want to be arguing about, or at least not arguing, but having discussions about, is whether or not the particular design of your application is serving the needs of the application, not just today, but in the future. So to go off on a little bit of a tangent, good architecture is really about reducing the cost of future change. So if a system has a good architecture, it should be cheaper and less risky to add features over time. When a system has bad architecture or bad design, it is increasingly risky and more expensive to add features over time. Okay, and so that's one of the reasons, or one of the main reasons, why we kind of make these types of decisions, is by ensuring that our business logic, that the things that are likely to change because the customer wants to add a new feature or changes a process, are isolated from the things that are likely to change because there's going to be some kind of a technology change. Okay, so we've hidden our database interactions behind this list. And let's say, for example, right now I'm using the MongoDB adapter. So this database, it's being injected here. So in contacts, at the entry point of contacts, it's being injected from this makeDB function, which comes in this database folder here. Okay, and that's where we're creating a connection to MongoDB. Now, obviously, I've hard-coded, my local host right now. In a real application, you'd be using process variables, and you'd have different environments, etc., etc. But I whipped this up sort of quickly as a demo. So so we've got the details of creating a database connection isolated into this function that is making our database, and it's injected here at the entry point of our contacts folder, right? So where we make the database, and then we inject it here into our contact list. So again, this allows us, if we wanted to, we could dependency inject a mock database so that we could test this code independently if we needed to test code paths that spoke to the database, because there's some branching logic in there that we're interested in. I guess the other thing I'll say about this is I happen to be using, you'll notice here, I happen to be using the driver that comes from Mongo itself. So this is the Nodejs driver that's given to us by MongoDB. That tends to be my preference when I'm interacting with the database, is just to use the driver that's given to you by the vendor. But I know that a lot of people like to use object data mappers or object relational mappers. And a popular one for Mongo is something like Mongoose. And so if I were to use Mongoose, what I would do is, rather than here in my contact list, instead of injecting this database, which gives me access to the driver and the functions of the driver, I would inject a contact model, so a Mongoose model for a contact, and then I would interact with the database using the contact model that's built with Mongoose. But a very important point is I would never use the Mongoose contact model as my business object. So I would still always have this contact object as a plain old JavaScript object, and that is where I'm going to put the majority of my business rules about a contact. Because again, if I rely on the Mongoose model to implement my business rules for a contact, now my business logic, the things that are likely to change because the customer or the client needs a new feature or has changed the way they work, is tightly coupled to some framework that is going to change for a different reason, which is, Mongoose is going to come out with a new version, or we're going to need to move to a different mapper because Mongoose no longer satisfies our needs, because either we've moved to a different database. And so you might think to yourself, well, hold on a minute. In my applications, or in the applications I've worked with, it's really rare that we change mappers or that we change databases. And it used to be that that almost never happened. Now, with my clients, there is more of, I shouldn't say that it used to be that it almost never happened. What it was that it there was almost never a compelling reason to do that. But now, with the way things work, more and more with my clients, I'm finding there are reasons actually to make these kind of changes. So a very common one that's quite relevant to the idea of a contact is, you might start out building your application where your contacts are in a proprietary, in your own database, and then you're going to move to a model where your client has invested in some kind of a CRM system, customer relationship management system, and now the contacts are inside of the CRM. And it would be handy from an integration standpoint for your API to repoint itself to the CRM as opposed to pointing itself to a custom database. And that's a lot more difficult to do if you've tightly coupled things with your database or with Mongoose. And what I mean by tightly coupled, obviously the list here is coupled to Mongo, but it doesn't contain any logic about what makes a valid contact. And even if I was using Mongoose, I would keep it light in terms of what makes a valid contact. That logic would not be in Mongoose. It would remain in my custom contact business object, which is here. Okay. So hopefully that's insightful and helpful. I'd love to take some questions. I see there are a few people on the chat. So let me hop in there and see what people are saying. And ooh, I love being live. Okay, so well, let's see if we can do. Can we do this? Haha. All right. So all right. So I don't know if people can see that or if it's worthwhile having this like this. It might go well. I mean, I think in the replay you'll have it there. But so yeah, so there are questions about returning frozen objects. So I think I covered that, but just in case. So the idea is the reason that we are returning frozen objects is that your data, well, actually, as T-John has said there. So basically, when you use object.freeze, what it does is it does what's called a shallow freeze of your object so that the properties cannot be changed from the outside. And so, yeah, so the properties would cannot be changed from the outside. The only thing to remember is that it's a shallow freeze. So if you have internal reference objects, then what's going to happen is you need to freeze those as well. In fact, I can, let's see, can we be brave? Let's see if we can be brave. And okay, let's see if we can be brave and actually go to and let's okay, haha. So let's see if I can make this. Can I make this bigger? Yes. Hopefully you guys can see this. All right, so let's make an object f equals object dot freeze. Sorry for the foo barring, but I'm old school. I come from the world where we called everything foo bar. Okay, so f is now a frozen object. So if I try to go f dot foo equals, baz, and do that, okay. So because I'm running in a particular version of JavaScript and Node, I had to make sure to specify use strict so that object.freeze would not fail silently. And so this is something that it basically depends on the version JavaScript you're using and how you've set up your build. So I've got Babel 7 running, and I've got things configured in my project so that it automatically enforces the strict rules. So you would actually get the error. What's happening, by the way, if I don't use strict, I'm pretty sure we're living on the edge. We're coding a lot. So what happens is if I don't use strict, and then I go console.log f.foo. See, so it actually logs bar. So this didn't work. But the problem with this particular environment here on this REPL is that by not using strict, it fails silently behind the scenes. So this line is actually not working. As you can see, I'm proving that down here. So hopefully that's helpful and that makes sense. And then what I was saying about shallow freezes. So if I have something in here like O, and then A, B. Okay, so if I have an internal object, this internal object I can change it. Like I can change f.o.a to something. So I would have to object.freeze this. As well. So hopefully that's clear and that's making a little bit of sense. So if you switch to CRM as your data store, would you still use the same database object to represent API calls to the CRM system? Yeah. So if I switched to a CRM as the data store, what would happen is the only thing that would change in my code, and this is the nice thing about working this way, is that the contact list, instead of receiving a database, it would receive basically the endpoint or some library that can interface with my CRM code, and then calls to my contact list would basically delegate and call out to the CRM, so that to the rest of this code, it has no idea that now these contacts are being stored and retrieved from a CRM. Our endpoint code actually doesn't change at all, right? So it still receives an HTTP request, delegates out to the contact list, and based on the response, it creates an HTTP response object. And so that's part of the value of working this way, is you really you isolate yourself from those kinds of changes. Okay, so oh. Hi, my brother's on the chat. Hello, bro. And so, okay, so the chat will be on the replay, apparently. So hopefully this was instructive and helpful. Please don't forget to subscribe and hit the notification bell. And if you have any other questions, if you're watching this video now or in the future in the replay, please feel free to put them in the comments, and I'll be happy to answer them all. So that's it. That's Mastery Monday for tonight. Thank you so much for joining me. Have a great night. Hope you enjoyed it, and we'll see you next Monday. Take care. Bye-bye.